end vertices, loop, and multiple graphs. Which one we have to call it as end vertices, which one we have to call it as loop, and which one we have to call it as multiple edges. So first we have to see the end vertices. If Vi and Vj are two vertices of a graph, G and Ek denotes an edge joining Vi and Vj. Then Vi and Vj are called it as end vertices. Okay. Here it is end of the graph. If Vi and Vj, these are two vertices. In between, Ek is the edge. So this is for Ek, Vi and Vj are there. No, these are the end vertices. If we should be consider this one. This is V1, V2, V3, V4. Wait, V1, V2, V3, V4. For V1, V2, E1, V2, V3, E2, V3, V4, E3, V4, V1, E4. So from starting point is also same and ending point is also same. This is the, we should be called it as, this is cyclic. Okay, so this is not a end of the graph. The starting point and ending point is same, means that type of graph we have to call it, we are not call it as an end of the graph. Okay, so this is the end of the graph because the starting point is different and ending point is different. Let's see another one example. This one. Okay, this is V1, this is V2, this is V3, this is V4. Okay, so here this is E1, this is E2, this is E3. So here starting point is different and ending point is different. So this type of graph we have to call it as the end of the graph. Okay. So here V1 and V2 are the end vertices of E1. We should write it. And V2 and V3 are the end vertices of E2. V3 and V4. V3 and V4 are end vertices of E3. Okay. If we should join this one, V4 and V1 are the end vertices of E1. That is not a correct thing. The starting point of the graph is different. The ending point of the graph is different. So that type of graph we should be calling it as an end graph. Okay. So what is loop? So what is loop? Loop is an edge in which both the ends are same. Okay. Or an edge joining a vertex to its left is called it as loop. Or another one definition is there, that is, in a loop of a starting and ending point of a edge are same, it is called it as a loop. Let's see with one example. This is one vertex is there. Okay, we have to study about here loop. Which one we have to call it as a loop? Just we have to see the definition. Now we have to understand with one example. This is G. This is one vertex is there. So this will be containing one loop. This one we have to call it as one loop. The starting point and ending point of this one, the edge will be same. So that one we should be call it as a loop. So this is V1, this is E1. This one we should be call it as loop. Let's see another one example. For example, G of this. This is containing V1 and V2. This is the simple graph is there. If it is containing loop, how it will be containing loop? The starting point and ending point should be same. This is the loop. if this one, this is E1, the loop we should be considered as an edge, that is E2. For example, if it is containing like this, if it is containing like this, is this is a loop? Is this is the loop? This is not a loop. The starting point is different, the ending point is different. The starting and ending point of the edge is same. So that type of, we have to call it as a loop. Okay. Next we have to see about next we have to see about multiple edges. The definition of multiple edges is two or more edges of a graph G are called multiple edges or parallel edges if these have same end vertices. If two vertices are joined by more than one edge, that one we should be call it as a multiple edges. Okay. So for let's see, we understand with example, that is multiple edges, multiple edges. So here, for example, this is one graph. So this point to this point, from here to here, it will be containing E1. This is E2. This is E3. This is E4. This is V1, V2, V3, V4. Okay. So from here to here, we are finding any multiple edges. Only one edge we are finding. From V2, V3, there are two edges are there, and the vertices of this connecting of these edges will be different. Yes or no? So this type of graphs we should be call it as a multiple edges. For example, V1, V2, E1. So if it is containing like this one we should be call it as loop. The connecting of vertices will be same. For this one, the connecting of vertices will be different. Okay. Let's see with another one example, that is G of 4 comma 4. That is like, if it is connecting like this, there is E1, E2, E3, E4, that is E5, V1, V2, V3, V4. So here the connecting of the vertices for this edge will be different. So this type of graph we should be call it as a multiple edges. Okay. We can take it edge like this also. Okay. But the condition is the vertices should be different. If the vertex will be same, so that one we should be call it as a loop. Okay. I hope you will be understand. Next is simple graph. A graph which does not contain loops and multiple edges is called as simple graph. Which one is called as simple graph? The simple thing is that simple. If we are not doing any makeup, then we should be calling it as a simple. So here also for simple graph, it will be not containing any loops and multiple edges. Okay. Simple graph, it will be not containing any loops and multiple edges. So that one we should be call it as simple graph. So G comma 3 comma 3. Okay. If it is 3 edges and 3 vertices. That is V1, V2, V2. This is E1, E2, E3. In this graph, anything you are finding edges and loops, multiple edges and loops. Edges are there. Multiple edges and loops we are finding here. There is no multiple edges and loops are there. So this type of graph we have to call it as a simple graph. If this is also be a simple graph, V1, V2, that is E1. There is no multiple edges and loops are there. If it is containing loop, this is not a simple graph. If it is containing any multiple edges, then it is not a simple graph. Simple graph that will be not contain any loops and multiple edges. So that one we should be calling it as a simple graph. Okay. Let's see the definition of multigraph. A graph which contains multiple edges but not loops is called it as multiple graph. Okay, let's see with an example. Multigraph. Okay, so here it will be containing multiple edges, but it will not contain loop. Okay, it will be not contain loop. It will only containing multiple edges. So that type of graph we should be calling it as multigraph. For example, this one. This is the multiple edge. Yes or no? This is the multiple edge. So this type of graph we should be calling it as multigraph. For example, another one. V1, V2, V3, V1, E2, E3. This is E4. It will be containing multiple edges. It is not containing any loop. So that type of graph we should be calling it as multi-graph. If it is containing a loop, that will be not a multigraph. It will only containing multiple edges, no loops. That type of graph we should be calling it as a multigraph. Next is general graph. A graph which contains multiple edges or loops or both are called as general graph. General graph is nothing but that will be containing multiple edges and loops. Will be containing multiple edges and loops. That type of graph we should be called it as a general graph. For example, we should take this one. V1, V2, V3, E1, E2, E3, E4, E5. It will be containing multiple edges and it will be containing loop. So this type of graph we will be calling it as a general graph. Let's see another one example. That is this is V1, V2, V1, E2, E3, E. Will be containing two vertices, but it will be containing multiple edge and loops. So this is called it as general graph. If it is not containing any multiple edges and loops, that type of graph it is not called it as a general graph. Okay, these two are the general graph. This is not a general graph because it will be not containing multiple edges and loops. Okay. Next is incidence. When a vertex V of a graph G is an end vertex of an edge E of the graph, we say that the edge E is incident on the vertex of V. Or when a vertex V1 and V2 of a graph G is an end vertices of an edge E1 of the graph, we see that the edge E1 is incident on the vertices V1 and V2. Let's understand with example. That is incidence. Let's take down example. V2, V2, V3, V4. V1, V2, V3. Okay. So here for this E1, V1 and V2 are the incidents. For this E2, V2 and V3 are the incidents. For this E3, V3 and V4 are the incidents. How we can write it? V1 and V2 are incidents on E1. V2 and V3 are incidents on E2. And V4 and V3 and V4 are incidents on E3. That one we should be qualitative as an incident. Or we can write it as E1 is incident on V1 and V2. E2 is incident on V2 and V3. E3 is incident on V3 and V4. Okay. Next is adjacent edges. If two edges incident on a common vertex, then such edges are called adjacent edges. For example, this is V1, V2, V3, V4 we are taking. So here E1, E2 are the adjacent to E1 and E2 are the adjacent to V2. Here E2 and E3 are the adjacent to V3. So this type of graph, this one we have to call it as an adjacent edges. Next is adjacent vertices. For this adjacent vertices, this is the opposite to this one. Okay, here we are finding the edges. So here we are finding the vertices instead of edges. Two vertices are said to be adjacent vertices. There is an edge joining them. So here this one is the vertices. V1, A, B, C, D are the vertices. E1, E2, E3 are the edges. So here A and B are the adjacent to E1. B and C are the adjacent to E2. C and D are the adjacent to E3. So that type of we have to call it as an adjacent vertices. Okay. Bipartite graph. A simple graph is bipartite if its vertex set of V can be partiated into two disjoint sets of V1 and V2. Such type of edge of graph connect vertex V1 and V2 vertex in V2. That is bipartite graph. Let's understand which example. Bipartite graph. If they are given like this graph, this is V1, just you have to take it, this is X1, X2, X3, V1, V2, V3. They have to given the this graph. This graph we have to convert it into bipartite graph. How you can convert it this into bipartite graph? This edges you have to see X1, X2, X3, V1, V2, V3. They have to given in zigzag order. So this type of graphs only we can able to convert it into bipartite graphs. Okay. So how we can consider this one into bipartite graphs? Means first we should be right here X1, X2, X3. Next we should write here V1, V2, V3. Okay. Next we should be draw the vertices. If it is only one, that one we should be call it as vertex. If it is more than one, then we should be call it as vertices. So here x1 is there. This x1 is here. X1 is there. Here x1 is there. This x1 is connected to v1. This x1 is connected to v2. how here connection will be made, no? Same connection, how to do it here. Then only that graph we should be call it as a bipartite graph. So x1, v1, x1, v2, x2, v2, v3, v1, v2, v3, v1. Next x3, v3, v2, v3, v2. So this graph is called it as a bipartite graph. This graph, the zigzag graph, we have to convert it into in terms of order. S2, x1, x2, x3, v1, v2, v3. So this type of graph we should be call it as a bipartite graph. Let's see another one example. Let's see another one example. X1, x2, x3, y1, y2, y3. If they have to even graph like this, you should convert it into bipartite graph. How you should do it? x1, x2, x3, y1, y2, y3. Always you should be draw the vertices also. So x1 will be connected to y1 and y2. y1, y2. First you should be draw here vertices. Okay. X1 will be connected to y1 and y3. Next x2 will be connected to y1 and y2. y1 and y2. Next y3 will be connected to x1 and x3. Sorry, x3 will be connected to y3 and y2. Is that x3 will be connected to y3 and y2. x2 will be connected to y2 and y1. So this one we should be calling it as a bipartite graph. This graph will be converted into this graph. This is zigzag order. This zigzag order will be converted into the correct order x1, x2, x3, y1, y2, y3. So this one we should be calling it as a bipartite graph. Next one is complete bipartite graph. Let's see the definition. A bipartite graph G of V1, V2, E is called as complete bipartite graph if there is an edges between every vertex in V1 and every vertex in V2. Let's understand with example. Whatever this number is given, no, you should write it like this: 1, 2, 3, 4. From this vertex, it will be go each edge. One vertex, there is 4 edges here. This is the complete bipartite graph. Complete graph, what we have to see, from each vertex having same number of edges. Here also each vertex having same number of edges. That one we should be calling it as a complete bipartite graph. This is not a complete graph. This is complete bipartite graph. Okay, why it is not a complete graph? From this edge to this edge, it is containing 4. From this 1, 1, 1, 1 is there. This is not a complete graph, but this is complete bipartite graph. If they are to given G of 1, comma 5. So how you can draw it? 1. This is 1. This is the V1. 2, 1, 2, 3, 4, 5. You just connect it. This is A, B, C, D, E. You can take this. So this is the complete bipartite graph. Okay. If we are connecting like this, if we have to given G of 2, 5. If we are connecting like this is not a complete bipartite. This is not a complete bipartite. Okay, let's see another one example, that is K of 3, 5. This will be denoted by K. Okay, 3 of comma. So 3 we should be take above, 5 we should be take 1, 2, 4, 5. So here this will be connected with 1, 2, 3, 4, So whatever the above is there, no, that should be connected with the below all the vertices. This is also connected with this one, this one, this one, this one, this is also connected with this one, this one, this one, this one. This is called as complete bipartite graph. If like this is connected with this one, this is not connected with this one. This is connected with this one, this one, this one. If it is not connected with this one, it is not a complete bipartite. If it is connected with this one, 1, 2, 3, 1, 2, both are connected with all the below edges. So that one should be called it as complete bipartite graph. I hope you will be enjoyed. Thank you so much.
Like, share, and subscribe.